Alright, so here we are for Chapter 6, Part B, Part 2. I couldn't finish the whole thing all in one recording. It's just not possible. So we talked about covalent bonding, polar covalent, nonpolar covalent, in our Part B, Chapter 6, Part B, Part 1. Now we're in Chapter 6, Part B, Part 2. We'll talk about ionic bonding and metallic bonding a little bit. So anyways, ionic bonding, typically it's formed from a metal and a non-metal. You have a very large electronegativity difference. If you think about that triangle En, that's electronegativity difference. And the idea is simple. The non-metal steals the metal's valence electrons. And this is where you end up getting the metal being positive, the non-metal being negative. So the positive and negative ions actually attract each other. Yeah, can you imagine that? So when we look at it, many ions clump together to form a crystal. And then there's this cartoon. Perhaps one of you gentlemen would mind telling me just what it is outside the window that you find so attractive. Well, if you look here, these guys, they're all cations. They are positively charged ions. And then on the outside, you have bromine and chlorine and fluorine, and they're negatively charged. So yes, it's natural that they are going to be attracted to each other. It works out that way. Now, with ionic, moving on here. So a formula unit, okay, a formula unit is the ratio of cations to anions. Like calcium fluoride, each calcium atom in the compound gives its 2 valence electrons to 2 fluorine atoms. So the example here, and I did not write it down, it's CaF2, calcium and 2 fluorines. These molecules will form something called a crystal lattice, a crystal structure, if you will. That's when you start going into metallic bonding, because that is the last kind of bonding. And this is more complicated compared to the covalent and ionic bonding, because here the electrons aren't quite playing by the rules. There is the electron C theory where you have lots of electrons that are not, they're delocalized, meaning that they're not hanging out with the nucleus of the atom. Okay? The electron C theory has these delocalized electrons where they're kind of floating around a bit. And this is what allows metals to shine. Because of those extra electrons, it also allows the metals to conduct electricity. Because of this electron C theory, it's the best explanation we can come up with at the moment. And yes, for metallic bonding, it requires an arrangement of metals in a crystal lattice. So here, sketch a crystal lattice. This is an example of an NaCl crystal lattice. Okay, crystal lattice doesn't just apply to metallic bonding. It applies to any kind of bonding where the atoms line up and they form some kind of a crystal structure. And that's what the lattice is. It's a structure. It's like a building in a way. Okay. Now we'll look at Chapter 6C, Properties of Compounds. So properties of covalent compounds, we have a low melting point. Well, why? Well, the thing about covalent compounds is that the attraction, yes, it's there, but it is kind of weak. And because it's weak, alright, because it's weak, there's not a whole lot of attraction. They're not dense, they're not hard, they're not the greatest of heat and electricity conductors, like sugar, like wax. Let's face it, we don't see wax wiring. We don't see sugar wiring for heat, let alone in wires, for crying out loud. There are network covalent substances. Now, covalent, again, sharing of electrons. It could be equal or unequal sharing, doesn't matter. Covalently bonded into a 3-dimensional network, a 3-dimensional structure, like diamonds, silicates made of silicon. They're hard and brittle, They have high melting points, glassy lusters, and unusual electrical properties. Now, going back into ionic compounds for a moment, because remember, ionic compounds, one atom loses an electron, the other atom will take it, so you have that positive-negative connection there. Strong bonds, they have a high melting point, they're dense, they're brittle, meaning it's hard to break, but when it breaks, and it's hard, you can't scratch it that easily. If they're dissolved or molten, meaning melted, they're good electron conductors like NaCl, KCl, and NaF. All those are examples, ladies and gentlemen, of good conductors. Okay? They work out great when you have that. So, alloy. As we're winding down our chapter here, an alloy is a mixture of two or more metals. We've seen alloys in many, many things, like wedding rings, for example. Typically, it's a mix of gold with some silver. I know there's titanium wedding rings, there's platinum wedding rings, there's different kinds. But if I just stick with your basic gold wedding ring, okay, pure gold will fall apart. However, when we go and look at gold combined with something else, well, that's another story. Okay, so for us, for gold that you can work it as jewelry, we need to have it combined with something else. And that's where you get your alloy. Okay, properties of metals and metal alloys. They carry electrical current and thermal energy. They have a luster. Now, a luster is a shine. Okay, that's a fairly important idea. The luster is a shine. They're malleable. They can be shaped. They can be rolled. Ductile, stretched into a wire. That's another thing that can be done with alloys, metals and metal alloys. They can have that. So those are the basics, ladies and gentlemen, for Chapter 6C as we work our way through properties of compounds, properties of covalent compounds, low melting point, fairly easy to break, not that difficult. Network covalent substances, think covalently bonded with 3D network, like diamonds. They're hard, brittle, high melting point, unusual electrical properties. And we looked at properties of ionic compounds, high melting points. They're strong bonds. Great electrical conductors if it's dissolved or melted. And then we talked about alloys, two or more metals mixed together, and then the properties that they have. Well, that's it for Chapter 6. Hope this works out for you, and hope you enjoyed the little pictures here of tanks from Ambush Blitz.